So we explore the three significances of the AI technologies for implementing sustainable business models. Then from this source research by the group in Germany, where they've grouped these significance of AI technologies into first part of sustainability of AI, sustainability through AI, and then the AI-based assessment for sustainability. So when it comes to the sustainability of AI, this explores the opportunities to reduce energy or materials consumption using AI to gain efficiencies. The sustainability through the use of AI then looks at how processes or business models can become more greener, efficient using AI. And then you have the AI-based assessments explores the AI processes in order to evaluate or monitor various sustainability commitments such as improvement in biodiversity or conservation or climate change. So under that same source for the platform also highlights some of the opportunities for AI to be used for sustainable development. So these are some of the examples of the positive impact, which includes efficiency gains, saving energy and materials, improved working conditions, making better use of existing systems, making savings in time, and improving the information processing. These are some of the key objectives that can be achieved using AI for sustainable development. So in terms of the key solutions for efficient resource utilization with AI technologies, then you have the energy efficient infrastructure such as recycling waste heat in various combined heat and power systems, improving the sustainability of the design, for example, incorporating pre-trained models, and then implementing machine learning in terms of reuse of pre-trained calculations and models as well. So we look at this case study where Google DeepMind AI was used to reduce the data center cooling bill by about 40%. So we explore this from the Google DeepMind site, which highlights how the DeepMind AI used the Google data center cooling bill by 40%. It was using machine learning over 2 years. What we have here is the graph highlighting when the machine learning control was initiated and when the machine learning control turned off. So we can see when the machine learning control was turned on, then the low power usage efficiency, and then as soon as it was turned off, then it went up to high PUE, which is highlighted here. So as we can see in the text, the key challenges is data centers using various parts such as chillers and pumps have higher energy consumption demand in order to remove the high amounts of heat generated in the servers as the servers are running. Traditional ways of understanding and the human intuition do not allow proper understanding of the various interactions that goes on within the system, and you have the system not being able to adapt to changes such as the weather, and you have the data center also having a unique architecture, and therefore the general human intelligence framework is not able to keep up with the key changes. Using the machine learning tools, average future PUE, which is the power usage effectiveness, then you have when the machine learning control was turned on, higher PUE reduces to a lower PUE, and then once the machine learning control was turned off, then it goes back up to the high PUE. So we see that from this graphical representation, the machine learning model was able to achieve the lower PUE. So in summary, we've just looked at the significance, the solutions, and the background for research and other key parts of how AI and digital technologies can be used to achieve sustainability. And then we looked at the case study of how Google DeepMind have used AI machine learning to be specific to reduce their energy bill, the energy content associated with it. So here is the list of reference used.